Hi, I'm going to have a look at the low-level workings of the ISOBUS Virtual Terminal standard and explain its purpose. So here is the standard, and everything you need to know in order to make a virtual terminal is defined in this document or documents that are referenced within here. So we've got explanation of the high-level workings, we've got definitions of serialized objects, and we've got definitions of CANbus messages and responses. The virtual terminal provides the capability to display information and to retrieve data from an operator. First of all, let me try and explain the problem that this standard solves. All sensor nodes and machinery that need to be monitored and controlled by workers need some sort of user interface. In a packaged commercial product, all the components are known and so can be integrated with the provided user interface. However, when machinery is assembled for a specific job, the exact sensors and machinery to be used are not known ahead of time. And so an agreed upon standard is needed to provide a user interface that all of the sensors and machinery can share, which is similar to how a browser and HTML came to be the user interface for web servers. Looking at the ISOBUS dictionary for process data and the vast amount of values and control messages, you can clearly see why a decentralized approach was needed, as a centralized approach simply would not be workable. In order to facilitate this dissociation of the user interface and the back-end hardware, there are a series of hardware messages to interrogate the virtual terminal, as well as session and status messages. Here we have the get hardware message, and here is the response, which tells us the virtual terminal's capabilities as well as its width. And here is the get keys message along with its response, which tells us the number of keys on the display as well as the width and height of the keys. And here is the virtual terminal status message, which tells us which device is currently being displayed and which screen is currently being displayed by that device and which button panel is currently being displayed. And here is the message from the terminal client that lets the terminal know if the client is still present on the bus. The life cycle of the virtual terminal and virtual terminal clients is clearly defined in the standard in this drawing here. First they announce themselves, and then they start sending their status messages, and then the client will send various messages to the virtual terminal and then load the object pool, which is the jargon for the user interface, and then the behavior of the disconnect is defined. Here I have a basic virtual terminal client script which lets me send various messages to the server and upload a user interface. So I've got the get hardware message, got the software key message, I've got get fonts, get versions, and then I've got do transfer, and then I print out the responses to these messages. I'm just going to make and compile a couple of basic user interfaces that I can then upload to the virtual terminal. There in the CANbus trace, we can see the get width message and its response. And here we can see the get keys message. And this block here is the transfer of the virtual terminal user interface information. You can then connect a different virtual terminal client that has hello world with a different background color. In conclusion, this is a very useful standard for building a distributed network of sensors and control devices.